Welcome to our transformations video. This is going to be looking at all different ways we can move objects around the coordinate plane. We've started looking at this, and today we really want to look at how we can move and describe the movement of an object around the coordinate plane. We're going to use three different main methods to do this. We have three different ways to move things around the coordinate plane. One that we looked at a bit before, our first transformation, is known as a translation. That's when we're moving, we're sliding, so you can see that just slid right into the screen right there. Our next one that we're going to look at is a rotation, or spinning. Lastly, we're going to look at reflections, which is like mirror images of the objects you see. And finally, just a little sneak peek for the future, we will eventually want you to look at things called dilations, which is how you grow or shrink an image on the coordinate plane, how you kind of compress it or enlarge it, but that'll be for the future. So we're only going to look at translations, rotations, and reflections for now. So we're going to be looking at this setup. I have my lovely turtle, bobblehead turtle over here, who's going to be moving around on this coordinate plane in lots of fun ways that we will then be able to describe. You'll notice that I have my x-axis that is labeled right here as a horizontal, and my y-axis labeled in purple as my vertical. So let's get started by looking at the one that we're most familiar with right now, are translations. Again, how we move, and we're just going to shift it. So if you look at this quick little video, just reminding us what translations look like, you'll notice that as I take my little turtle, I can move him up, down, right, left. You can see that a lot of people call this a slide, a glide, or a shift. But notice that he started by looking up towards the positive y direction, and he continues looking up. So he doesn't flip over at any time or anything like that. So those are my translations, and you can describe them just like moving around city blocks. Move up 2 blocks, go to the left 3 blocks, -4 blocks, those sort of things. Our next one that we're going to look at is our rotations. We have 2 different ways to rotate. We have clockwise, which this is the way that clock hands move around a clock face. So if you watch a second hand count down, that's the direction it goes. And counterclockwise, which goes against that direction, the opposite way. In my little video here, we're going to spin the little turtle. He's actually going to go clockwise. So you'll see that we're going to start over here in our third quadrant. Let's label our quadrants real quick. Here's our first quadrant, second quadrant, third quadrant, and fourth quadrant right over here. So I'm going to be spinning this away. So from the third quadrant, he should end up in the second, then the first, then the fourth. And we're going to actually kind of map out where he's going here. So he starts off here, my red dot is right in the middle of him, and he starts off at the point, what is this, -2, 1, 2, and -3. Let's start our video and see what happens. Oh, there we go. So notice my finger's right at the origin, trying to keep that center really clear. You'll see things aren't perfect. Oh, and now you'll see that, oh, he just made it to -3, +2 in that second quadrant. Oh, I had to shift him a little bit. Oh, sorry, he fell. He should have been over there. That's all right. But now he's at +2. He should be at +3. Sorry, the 2 is off. And then he comes back around here. He is at, should be again 2. 3, -2. And then he should end up right back where that dot was. Sorry, again, he slid out of the way a little bit. But notice how he just shifts around. And the big thing that I want you to notice in that video is that when he was turning, he starts by looking up this way. But then when he turned, now he's looking towards the right. And then when he turned again 180 degrees, he looked towards down, -y direction. And then he looked to the left. So that's a way that we can get our object to look in different directions, to really spin around. Finally, our reflections are mirrored across an axis. This is basically when you flip an image. So you might have done this when you were much younger. You might have done it yesterday. That's totally okay. You take a paper, you fold it in half, and then you're like, I'm going to make a butterfly. And then your teacher, your parent, someone tells you, okay, now just smash these 2 pieces together and trace it on the other side, and you did just that. You reflected this image across the other side, and you got this beautiful butterfly. Look at you go. So that's the same thing we do with reflections. All we're going to do is we're going to take one pre-image, and we're just going to map it onto the other image. Now for this, you need an axis. The axis is the thing that you're reflecting across. It's the thing that's right in the middle. So in this case, it would have been this line right here. What's in the middle separating the left side from the right side. So here's an axis, for example, this big purple dashed line. If I were to mirror this image, the mirrored across this axis saying, across this axis, the purple dashed line, it would look like this. I just take it and, oh my goodness, it just looks like a mirror image. And the axis doesn't have to be this horizontal thing. It could also be a vertical one if you wanted. And we'll look at diagonals later again. That's another sneak peek. But now let's look at this red dashed line. If I were to reflect my original pre-image mirrored across this axis, across the red axis, there it is again, mirrored beautifully. So again, you can kind of notice that the distances are about the same. Like this dot over here was this far away from the red line, and now it's kind of the same distance, just opposite direction across from that red line. Same thing, let's look at this. R right here is pretty close to this axis. R right here is pretty close to this axis. So it's a kind of fun way that you can look at those images. Let's look at some examples with our turtle. Here he is. Again, I want you to note the direction that he's looking in. So on the left side one, here he is. He starts off at the point, 3, -2. And then it kind of looks, if you look in that mirror image, I've put this mirror up right along the x-axis, and it kind of looks like he's at the point, still 3, 1, 2, 3, but now he's 1, 2 up. So notice that it flipped over, and before he was looking up towards positive y direction, but now he's looking down right at us at the negative y direction. So everything really reflects and turns around, it flips around in this. I also have this other image on the left down here. You'll notice I wanted to show this one because he started looking in the negative x direction, and in his image over here, it still kind of looks like he's looking out towards the left in the negative x direction. So it does depend on how we reflect, even though this is still reflecting over the x-axis. And on this one, just for funsies, we can map out, he looks like he starts off at the point 3, 1, 2, 3, negative down, and then it looks like his image is 1, 2, 3 over, and 1, 2 up, 3 up. So just kind of notice, I just want you to start feeling familiar with how those coordinates might be changing and flipping around on here. Or, of course, we could flip over a different axis. So here's him looking again at another reflection, or actually not looking, because he starts out looking out to the right in the positive x direction, but then in his image, all you see is his butt. He's looking out towards the left in the negative x direction. So again, notice that the way things are facing has flipped around. And again, let's look at position. So he starts off at 4, +1 in the first quadrant. Then he flips along that y-axis line right where I'm placing my mirror. And now it looks like he's 1, 2, 3, 4 back. So he's now in the -4 and 1 up, still up. So now look at how we flipped around on those. We have that opposite there. Oh, let's go forward. All right, so how do we use those? I'm going to go through an example of how we want to describe, how we use our transformations to describe the movement of images along a coordinate plane. We have 3 different ways that we're going to use those transformations. Remember that we can use translations. That's when we're shifting, we're gliding across, we're just moving. We can use rotations. That's where we spin things around. And we can use reflections. That's where we flip something, where we look at it in a mirror. So our example, we're going to start with our little turtle over here, and then we're going to end up with him over here, and I want us to describe what do we have to do this? What sort of moves do we need to make? How do we translate? How do we rotate? And how do we reflect? So I'm going to take our image that we're going to try to make, and I'm just going to snag it out. Here's our goal. This is where we're trying to go. So eventually I want to get this little turtle right on the point. It looks like 1, 2, 3, 4, 0. That's my goal. Is I want to get into the point 4, 0. But where does he start? Our starting place, or our pre-image, is right over here. And I see that he's at 2, 4, 6. He's back 6 and down 2. So he's starting off in that third quadrant at -6, -2. Somehow has to go to 4, 0. Now I have to say there's a lot of different ways to see how this happens. Kind of giving you a spoiler with the first step I would take, but it doesn't have to be the first step you would take. There are lots of different ways to make this happen. I just happen to have been, I'm going to lead you through the way that I see this. You might see it differently because we are different people, and that's lovely. The more that you can understand how you see things, the better of a mathematician you can be. So the first thing that I recognized is that not only did the placement of this turtle move, but also the direction that he's looking he starts out by looking off towards the right in the positive direction, but at the end he's actually looking down in the negative y direction. So that to me, that's what told me I need to rotate. So I said I'm going to rotate 90 degrees clockwise. So I'm going to bring him up and I'm going to shift this so he goes whoop and it's looking down this way. You could have said I want to shift him 270 degrees counterclockwise. Whatever works for you. This is all up to how you see things. So I'm going to go ahead and show that shift right here. So I rotate him around the, there we go, rotating around the origin. So notice he started off at that point, 2, 4, -6, -2. This is our starting point. And now he's actually up at this point, which is at 2, 4, 6. Whoops, that's not how that is counted. +6, -2. So notice that we've shifted this all around. So now he's still kind of the same distance away from this origin, which makes sense with rotations, but he has a different orientation. He's looking a different direction. All right, so that's not enough though, because our images still aren't the same. So I'm going to continue. Here we are, we're still thinking about, okay, well, I'm going to keep him right here. He's starting off at -2, 6. But now I'm saying, okay, he's looking the right direction, but he's not in the right place. That tells me I got to move, I got to slide him. I'm going to translate. So first thing I did is I said, let's get him in the right x direction. So I translated him 6 units to the right. There he is. Now we're seeing him at 4 and +6. That's looking good because all I did was I translated him 6 units to the right. He started off at x equals -2. Add on 6 units to that. Now I'm at 4. That's good because remember that I want my goal is at 4, 0. So that matches. I'm happy. And then finally, I'm going to try to translate 6 units down. Oh, before I do that, so again, I'm going to write down where he's at right now. We're at 4, 6 here. Let's translate 6 units down. That means I'm going to remove 6 from the y. So 6 minus 6 equals 0. I should end up at 4, 0. Let's see. Bink. This is at 4, 0. That's at 4, 0. This is looking good. I'm feeling happy about it. Does it match? Yay! So these are some steps that I could take to describe that movement. How did I get from one place to another? So thank you for watching. Remember, you can use translations, rotations, reflections to transform images to describe how images move.